Hi everyone, welcome back to Power Electronics session 8. We discussed voltage commutation circuit in the previous video and we discussed two issues in that circuit. One is commutation process is depending on the load current and other one is capacity or size of the main thyristor is depending on the commutation circuit. To avoid these two issues, we generally use current commutation circuit, nothing but class B commutation circuit. Now we will discuss class B commutation circuit. In class B commutation circuit, the circuit parameters more or less similar to voltage commutation circuit, but the arrangement will be little different. Obviously, operation will be little different. So now we will discuss about current commutation circuit and then operation. As we discussed in voltage commutation circuit, here also we are going to take the DC to DC converter, and in this DC to DC converter we will actually make the prepare the commutation circuit for this main thyristor TM. So in this case, if you want to turn off this main thyristor TM, we need to use the commutation circuit. So to use the commutation circuit, we need to to commutate this thyristor, we need to connect some circuitry. So how exactly this circuitry will be there, we'll see that. Okay, so in this case also capacitor will be there, then inductor, one diode will be there here, next auxiliary thyristor which will be connected across the LC circuit. And as we discussed in case of class D commutation circuit, here also initial voltage across the capacitor must be like this. That means left plate must be positive, right plate must be negative, and it should be charged to source voltage VDC. Okay, and this will be auxiliary thyristor TA. Okay, so this is the circuitry we will use for current commutation. The main difference between the voltage commutation and current commutation circuit is when you start the commutating the thyristor, in case of voltage commutation, charged capacitor will be appear across that, but here charged LC circuit will be appear across that one. So that's the main difference between these two. And for the convenience purpose, we will assume that tank circuit current or capacitor current will be taken as a positive like this. Okay, so this is a circuitry we will use. All the circuitry which is drawn in blue is the commutation circuit required to commutate this thyristor. Okay, so this is what we will discuss, and we will see that what is the operation of all these things at all. Okay, so as I told you, initial voltage should be like this across the capacitor, and auxiliary thyristor is required, and we'll see that what will happen, etc. So when thyristor is not turned on, that means main thyristor is not turned on. Assume main thyristor is not there, and that means it is not actually a turn on. If it is not turned on, then it will act as an open circuit. Now look at here. You are not mentioning anything about the auxiliary thyristor, means it is actually already open circuited, and diode, no current is flowing through that. That's why it is also open circuited. At this time, there is no path to discharge the capacitor, so that's why here it will remain. That means capacitor voltage will remain at VDC. Okay, so no current flowing through the tank circuit and no thyristor current. Now assume we need to supply the power to the load by source. In that case, we are actually turning on the main thyristor. If you turn on main thyristor, then it will act as a short circuit. That means it will carry the load current. So it will carry the load current which is supplied by the source I0, which is equal to capital I0. Okay, constant current. So now at this point you can see that so main thyristor is actually turned off. That means this capacitor will also try to discharge, but as we don't know that diode is connected like this. So diode is connected like this means this will not allow the reverse current. That means still it is open circuited. So if it is open circuited means still there is no path to discharge the capacitor. That means capacitor voltage remains same. So now in this case nothing is happening on the commutation circuit. Only the thing is here source voltage is actually supplied. That means source is supplying the power to the load. That's it, nothing else. Now to start the commutation of this thyristor, then we need to start the auxiliary thyristor first. That means we need to prepare the commutation circuit to turn off this thyristor. So in this case, before starting the commutation, we need to turn on the auxiliary thyristor. As we already discussed, auxiliary thyristor is connected like this, and positive voltage is appearing here. That means it is already forward biased. So by giving the gate voltage to this, then we can turn off. If you are turning on, then it will act as a short circuit. If it is acting as a short circuit means, now look at here, this capacitor start discharging like this and flowing through the auxiliary thyristor and supplying this to inductor. That means now the current is flowing through that. So now whatever the energy is available with the capacitor is transferring to the inductor. Nothing but inductor is getting charged. During this process, all the energy will be transferred. That means voltage across the capacitor will be slowly reducing, and the current flowing through the capacitor or inductor, both are in series. That's why current will be increasing. As we already discussed, this is a tank circuit. In that case, capacitor current or inductor current will follow the sinusoidal waveform, but voltage across the capacitor will follow the cosine waveform. After 90 degrees or 5/2 radians, the voltage across the capacitor will be 0. That means all the energy transferred to the inductor. At that time, current flowing through the capacitor or inductor will be peak value. That means it will be maximum. Okay. Now after that, this inductor, whatever the inductor is actually already getting charged, already charged by the capacitor, will start discharging. That is nothing but this capacitor will be charging in this way. That means still inductor will actually discharge in the same direction of the charging current. So now the current is same. That means now the energy is transferring back to the capacitor, but this becomes positive plate and this becomes negative plate. So this keep on having like that. Once this voltage across the capacitor becomes VDC, that means the current flowing through this circuit will be 0. Nothing but all the energy available with the inductor is transferred back to capacitor. Once the current becomes 0 means this thyristor will be turned off immediately. That is just like a class A. That is nothing but load commutation. Once it is turned off, then obviously this current becomes 0, and then thyristor will be open circuited. So what happened in this case? By turning on the auxiliary thyristor, we just done voltage reversals across the capacitor. So voltage reversals across the capacitor is done. So now once this voltage across the capacitor becomes VDC and auxiliary thyristor is turned off, then this capacitor start discharging in this way. So in this way means we already know that diode is connected like this. Now diode will be turned on. So it is turned on by the capacitor positive current. Now this will be start flowing like this. If it start flowing like this means this tank circuit is also supplying current and source is also supplying current, but load is drawing only the constant value. That means load current I0 equal to sum of the source current and tank circuit current. So now this load is drawing the constant current I0, that is the sum of these two currents. That means this in capacitor keep on discharging means this current is actually, as we discussed, it is keep on following the sinusoidal waveform. Once this capacitor current start increasing like this, then this will be keep decreasing like this. That means to maintain the load current constant, capacitor current increasing means source current has to be reduced. Once this source capacitor current IC reaches to I0, then this becomes 0. This becomes 0 means this is the current flowing through the main thyristor. If this current becomes 0, then obviously main thyristor will be turned off. If main thyristor is turned off, then obviously it will act as an open circuit. Now you can see that load is not disconnected from the source. It is still connected through tank circuit and diode. Okay, but only the difference is here. Here what is the difference? We are seeing thyristor, main thyristor is turned off, that's what. But now the current is actually flowing through the auxiliary thyristor, diode and tank circuit. That means source is still supplying the power to the load through the tank circuit, that means LC circuit, diode, and then like this. So now in this duration, whatever the energy available with the capacitor plus this DC source, both will supply the energy to the load with the constant load current. That is nothing but capacitor will be discharged with the constant load current. In that case, the voltage across the capacitor is slowly reducing to 0. Once this capacitor voltage becomes 0, then it is again start charging in this direction. That means in the same source current direction, in this way. That means this becomes positive, this becomes negative. Once the voltage across the capacitor becomes source voltage VDC, then this current will be disappear. If this current is disappear, then now the load current is actually following through the freewheeling diode. In that case, this load is completely disconnected from the source. So that means we achieved the turning off process of the main thyristor. So now load current is keep on flowing through the freewheeling diode. So that is the operation of this circuit. But remember, in all the case, that means throughout the operation, the current flowing through the main thyristor is only load current. So this is one of the issue we discussed in the voltage commutation, that is overcome. Understand? That overcome. That means this main thyristor capacity or size of this main thyristor is only depending on the load. So that's one of the advantage. Second thing we discussed in the class D commutation, that is nothing but this commutation process, nothing but voltage reversals across the capacitor is depending on the main thyristor, nothing but load current. But now here, because of this arrangement, that means we are actually able to change the voltage across the capacitor independent of the main thyristor or load properties. That means here this commutation circuit is independent of the load properties or independent of the main thyristor duration. That's why we can able to overcome whatever the issues we mentioned in the voltage commutation circuit. That is why most of the times we will use the current commutation circuit in DC to DC converters and inverters. So this is the operation. Same thing we will discuss with the help of equivalent circuits, and then we will draw the waveforms. From the waveforms we will discuss some important equations. Okay, so move on to this is a circuit as we discussed. Move on to the first thing what actually we discussed is like this one. So if main thyristor is not in conduction, then auxiliary thyristor is not in conduction, and diode will not be in conduction. In that case, voltage across the capacitor will be constant. That means there is no path to discharge this capacitor, and the tank circuit current will also be 0. So that is the first circuit. And if you look at that, main thyristor is turned on, then obviously you can see that. So this thyristor carrying load current I0, okay, that is supplied by the source. But still, if this capacitor try to discharge in this way, but this diode will not allow. That's why this capacitor voltage remains same at VDC, and current flowing through the tank circuit will be 0. That means through the main thyristor only load current will be there, no other current. Now to turn off this conducting thyristor, that's nothing but to commutate this thyristor, we need to prepare the commutation circuit by turning on the auxiliary thyristor. If you assume, if you turn on the auxiliary thyristor, then in this case voltage reversals across the capacitor will be started. That means current flowing through the main thyristor still remains same at I0. Now the current flowing through the tank circuit will be following the sine wave here, that is through the auxiliary thyristor. Understand, this is IC. So this is what happening, that means slowly this capacitor energy is transferring to the inductor, and then voltage across the capacitor will be reduced, current flowing through the inductor will be increased. So that's what is happening here. So at one point of time, all the energy will be transferred to the inductor. In that case current flowing through the main thyristor will be same as I naught, but here voltage across the capacitor will be remains 0, but tank circuit reaches the maximum current. That means all the energy is transferred to inductor. So here voltage across the capacitor will be 0 at that time. After this is general happens at 90 degrees or 5/2 seconds after turn on the auxiliary thyristor. So that means current will be maximum, but voltage across the capacitor will be 0. Now after, that means you can say that after this instant, this inductor discharges in the same direction of the current. Okay, discharges in the same direction of current. That means all the energy available with the inductor will be supplied back to capacitor. In this case, current is actually moving like this or supplying to the capacitor like this. That's why this becomes positive and this becomes negative plate. So once this capacitor voltage start increasing to the maximum value, okay, at this point what will happen? So voltage across the capacitor will be maximum, current in the tank circuit will be 0. This will happen at 180 degrees after turn on the auxiliary thyristor. So here all the energy available with the inductor will be transferred to capacitor. So now the current in the tank circuit is 0, nothing but auxiliary thyristor current is 0, then obviously this will be turned off. But still in this case, load current will be flowing through the main thyristor. Okay, so now look at here. So auxiliary thyristor is open circuited, that is actually turned off by the load commutation, what we discussed in the class here. So now you can see once this is open circuited, now the capacitor try to discharge in this path, and then diode will actually allow that one. So now the load current, whatever the I naught, which is supplied by the two currents, that is the source current IDC flowing through the main thyristor, and other current will be capacitor current. So that's what is happening. Now here in this case, so this equivalent circuit is nothing but once this capacitor current, whatever the current is flowing through the capacitor is already reached the I naught. So that means this capacitor current itself I naught. In that case, there will not be any current flowing through the main thyristor. Then the main thyristor will be turned off, and it becomes open circuit. So now the load is getting the current through the tank circuit. During this period, as I already told you, this capacitor have the polarity like this. That means, so which is aiding nature with the source voltage. Okay, so in that case both will actually supply the energy to the load. That means this capacitor is getting discharged with the constant load current. Once this is completely discharged, then it will be charged again by source itself with constant load current. Okay, so that like this. So in this case it will be supplying like this. That means once this is actually like it is flowing through the diode like this. So once this voltage, that means voltage across the capacitor, becomes VDC, that is nothing but source voltage, then this current becomes 0, that is nothing but here no current flowing through the capacitor, and diode will also be open circuited. So if it is open circuited, then obviously this load current is flowing through the diode. That means there is a framing action. So this is what the operation of this commutation circuit. Now we will discuss about the waveforms. Okay, now we will look at the waveforms what we discussed already. Same thing we will actually take that. As we already discussed, once you turn on the main thyristor, it always carries the load current only. That means load current is already we discussed, that's a constant. So that means we will take the load current as a first waveform, that is constant at I naught. That means this is the load current I naught, and we will take the main thyristor current, that is also same as the load current, which is almost constant at I0. Okay, so there is no other current flowing through the main thyristor when it is in conduction. That's one of the advantages of the current commutation circuit. Now we will take the other current waveform is here nothing but capacitor current. So capacitor current is actually, if you take capacitor current, is actually initially will be 0, because when if you are not turning on the auxiliary thyristor, then there is no path to discharge the capacitor. That means tank circuit current will be 0 initially. So initially the current flowing through the capacitor will be 0, and voltage across the capacitor will be maintained at same value, that is initial value is VDC, source voltage. So this is VC. So now you can see that at this point of time we are turning on the auxiliary thyristor. That means at this time we are actually preparing the commutation circuit ready for the commutation. Once this thyristor, auxiliary thyristor, is turned on, as we already discussed, if it is turned on, then this capacitor supplies the energy to the inductor. As we already know, so current will actually follow the sine wave and voltage will follow the cosine wave. So that means current is slowly increasing to max value and voltage will be reducing to 0. So that's what. And after that, complete energy is actually transferred to the inductor, means again inductor will transfer the energy back to the capacitor. In that case, similar one, that means current is actually flowing through the capacitor or inductor, so will be, and then voltage will actually reaches the maximum value on the other side, that is nothing but like negative direction. If it is negative direction, then obviously reaches the maximum value, but that is nothing but VDC. Okay, so then current is actually comes to 0. At that time this main thyristor will be turned off. If main thyristor is turned off, then the capacitor forces this diode to be turned on. In that case, load current I0 will be supplied by the both the things, sum of the, like it is sum of the source current and capacitor current. That's why in this duration capacitor current follow the sine wave and it slowly reaching the I0. Once till the point this voltage will follow the cosine wave, because it is a 90-degree phase shift. So till this point, if you look at main thyristor current will be as it is, that is nothing but till this point nothing is happened on the commutation, so that's why it will be. But once the capacitor start discharging in this way through the diode, then this current will also be supplied to the load during that time to balance the like a load current constant. Current flowing through the main thyristor will be 0, like becoming 0. So once this reaches the I0, then this current becomes 0. So now this load current is actually supplied by the source through the tank circuit. That's why this current will be constant at I0, as we discussed already, and thyristor is already turned off. That's why this current will be 0, and load is actually still connected to the source through the tank circuit. That's why it is coming from the source only. During this time, first initially this capacitor is actually start discharging with constant load current. That's why it is actually like a follow the ramp, and then it will again charged by the source in opposite direction. That's why this is again ramp, because the capacitor current is actually capacitor current is constant. Once this capacitor current reaches the VDC again, then load will be disconnected from the source. In that case, capacitor current comes to 0, and this load current remains at I0, but during this time onwards, from this time onwards it will be freewheeling. So that means from year to year it is supplied by source, and this one onwards it is freewheeling. Okay, so then you can see that commutation circuit again becomes normal, that is nothing but back to the original state. Okay, so these are the things. related to class C commutation, class B commutation. So now if you take the timing here, something like this is T1, this is assume T2, this is T3, this is T4, this is T5, and so on like that. Actual commutation processes started from T3 to T4. So that's what. So now here this actually becomes I0. Okay, so now here we need to look at some equations. What are the equations here? As we discussed in the previous circuit, so first thing is maximum current flowing through the main thyristor is always I0. Then maximum current flowing through the auxiliary thyristor. But look at here, in which duration auxiliary thyristor is in conduction? Auxiliary thyristor is in conduction when the tank circuit is having the voltage reversals across the capacitor. That is happening from T1 to T3. Till this duration auxiliary thyristor is in conduction. You can see that voltage reversals is happening. So during that time current flowing through the auxiliary thyristor is nothing but IC, but IC will be maximum at this point. So that means here maximum current flowing through the auxiliary thyristor will be IC max. We already discussed IC max is nothing but initial voltage across the capacitor, that is VDC, into root of C by L. Okay, that's one. So these are the two equations we already discussed in the voltage commutation method also, similarly here also, but these will be little different from those. Okay, these are the two equations. Another equation, we need to find out what is the time in which commutation process is actually, like in which commutation process is there. That's nothing but like at what time commutation process is started, at T3, at what time it is actually stopped, T4, what is the duration, that we need to calculate. How to calculate that? So you can see that, so if you look at this waveform, so here during this time you can see that current is actually in tank circuit, current is slowly starting from 0 and reaching I0. That's nothing but using the current equation you can find out that one. So if you want to find out that, we need to use the tank circuit current equation. IC equal to IC max sin omega naught t. That's what we know. So from this you can calculate, you can substitute all the things. At the time of T3, that's what we are actually calculating this time, that is assume some Tx. That's what we are calculating. That time current is actually reaching the max value I0. That's what you can take it here, I0, IC max, and into sin omega naught Tx. How to calculate that? Tx, take out the Tx out. So Tx is nothing but sin inverse of I0 by IC max. So this is what. But if you want to calculate this, you can actually, if you want to convert this into different one, we can still convert. How to convert? So either you can actually use that ICM, that's nothing but like a IC max, you can substitute, that we know VDC by R, VDC into root of C by L, or otherwise you can leave it here. Sorry, this is whole divided by omega naught, but omega naught is nothing but 1 by root LC, so you can multiply into root LC. That is what. Okay, but why we are calculating this is nothing but what we have done here. First thing, like first we actually turn on the main thyristor, and after some time at T1 we turn on the auxiliary thyristor. Then voltage reversals across the capacitors happened, that is after 180 degrees it is started processing the commutation. So now assume both the thyristors are turned on together. That means at t equal to 0 both the thyristors are turned on. But in this case we already discussed here waveform, assume in this case at t1, at t equal to t1, assume both the thyristors are turned on together. Then what is the time in which main thyristor is turned off? That's nothing but if you turn on the both the thyristors here, then main thyristor is turned off here. So now we need to find out what is the time in which main thyristor is in conduction. So this is the T. How to calculate? We already know this is the Tx. So, and we already know that this is nothing but like to happen this voltage reversals, it will take pi radians, and this is the omega naught. So pi by omega naught, that's nothing but pi into root LC. So this we know, then we can calculate. So that's what we need to look at here. So the time in which main thyristor is in conduction when both the thyristors are turned on together, that is nothing but pi into root LC plus Tx. Tx is nothing but sine inverse I naught by ICM into root LC. So here both root LC is common in both things, then you can take that pi plus sine inverse of I naught by ICM, okay, all multiplied with root LC. Remember this, like based on this one gate exam question is also there. So in that case you may get wrong answer because of one problem while doing the calculation. That's nothing but, here you can see that this is a pi, that is in radians, and sine inverse something your calculator will give you in degrees, but when you are actually using this equation means it will give the wrong answer because one is in radians, other one is in degrees. That's why in your calculation while calculating this must be converted into radians, otherwise you won't get the proper answer. Okay, and another important thing is nothing but to happen this properly, that means this Tx or maybe T and all, this I naught must be lesser than IC max. What exactly meaning of that? So here to turn off the conducting thyristor turn off the conducting thyristor Tm using current commutation circuit, your tank circuit should be arranged such that maximum current flowing through the tank circuit must be more than I naught. If it is not at all more than I naught, then obviously you can't turn off the conducting thyristor. That's nothing but always some current is flowing through the main thyristor. In that case it won't be turned off. So that's the meaning of that. That means condition is here, tank circuit should be selected such that maximum current flowing through the tank circuit must be more than load current. Next we will discuss about the Class C commutation circuit, which is also called as a complementary pulse commutation circuit. This is a large circuit in case of commutation. So now we will discuss about that. So the circuit diagram for this Class C commutation circuit will be like this. We will have like two loads here, R1 and R2. These will be supplied by the respective thyristors, and capacitor is required to commutate the thyristors, and we will see that operation. But there is no precondition for the capacitor such that it has to be initially charged, so on, so that's not required in this case. Okay, we'll discuss how exactly will be happening here. Assume the thyristor T1 is actually turned on to supply the power to the load R1. Okay, if thyristor T1 is turned on, then obviously it will act as a short circuit and then current will be supplied to the load R1. But initially there will be two currents here. So one current will be flowing through the R1 T1 like this. Okay, that is the one current, that is you can take it as a I1, and there will be another current which is related to charging current, that is actually flowing through the capacitor charging current, that's flowing through the like this, that means R2 C and then T1. So this current will be like this. So this is actually used to charge the capacitor, that means capacitor charging in this way by the source. So once this capacitor voltage becomes like a VDC, then this current will be disappear. Once this current is disappear, then this charging current won't be there. In that case you will have only source current which is flowing through the resistor R1. That means this is disconnected, this circuit will not be there. Okay, so that's what will happen. That is nothing but like in this case what will happen, you will see that only I1, that I1 is nothing but VDC by R1 only. So that's what happened. Now if you want to turn off this conducting thyristor T1, we need to turn on other thyristor T2. So if you turn on the thyristor T1, then it will be in conduction, and T1 is like this, it is already in conduction. You turn on thyristor T2, then it will be in conduction, and T1 is already in conduction. In that case, what will happen? This capacitor is actually suddenly appear across the conducting thyristor T1 in reverse biased. That means this will be the equivalent circuit. So for the thyristor T1, so thyristor T1 is already connected like this, okay, which is in conduction. But at the time of turning on the thyristor T2, this is the meaning. So here it is actually like a T2 is turned on, means this will act as a short circuit. That means this potential point and this potential point will be there. This and this are same. Then this capacitor will be connected across the T1 like this. If the capacitor is connected across the conducting thyristor T1 like this, means it will act as a voltage source. And how this voltage polarity is already there? This is minus, this is positive. That means this is the reverse biasing voltage appearing across the thyristor T1. In that case, this thyristor T1 will be turned off. That's nothing but by voltage commutation process. So if it is turned off, then initially two currents will be flowing through the main thyristor T2. So one is like load current, that is R2 T2, that's like a kind of I2 will be there, and another current is nothing but so discharge current through the capacitor. Now capacitor will be discharged through the main thyristor T2, but this current will be there sometime only. How exactly? Once this capacitor is actually discharged, that means this voltage polarity will be disappear. Once that the voltage polarity across the capacitor will be disappear, then it will be charged again by the source voltage with the same direction. That means same direction it will be charged. Then it becomes positive, this one, this will be negative. Once again this actually reach to the VDC, and then this current becomes 0. So then this I1 will not be there. Okay, so then this current will not be there. In this duration, this current flowing through the thyristor T2 is nothing but load current or I2 only. So that's flowing through the R2. That means this capacitor is ready for the commutation. If you want to turn off this thyristor T2, then we need to turn on the thyristor T1 again. If you turn on the thyristor T1, then again this capacitor, this voltage potential point, okay, sorry, this voltage potential point and this voltage potential point are similar. That means this will act as short circuit. Nothing but this capacitor voltage suddenly appear across the thyristor T2 in reverse direction. That's nothing but it will appear like this. So this is T2 connected like this, and capacitor is connected suddenly now like this, which is charged capacitor, and this voltage polarity is reverse. So it is reverse biasing that. That means this conducting thyristor T2 will be turned off. Once this conducting thyristor T2 is turned off, then T2 will be taking care of the current conduction. So current will be shifted to the T1. So in that case, initially two currents will be there. One is like load current as usual, that is I1, and other current will be there, discharge current. Capacitor will be discharged now like this, and then after that it will be charged again and then ready for the commutation of this capacitor. That means here that means other thyristor has to be turned on to turn off the conducting thyristor. That means here we need to turn on the other thyristor to turn off the conducting thyristor. That is why it is called as a complementary pulse commutation. Okay, so two things we need to discuss here. One is like the circuit turn off time. So here we need to discuss two things. One is circuit turn off time of the thyristors. Circuit turn off time of the thyristors for T1 is R1C log 2 base E. Likewise, for thyristor T2, circuit turn-off time is R2C log 2 base E. So these are the two equations related to respect to thyristors. I am stopping, and I can conclude we completed commutation circuits. And in the next session we will discuss about some of the gate questions. Thank you.